Here is a list of all of the problems that I'll be covering in this video. So if you'd like to skip ahead to any one of these problems, please click the appropriate link to the side. Okay, I want to add these two polynomials, so I'm going to start off by just writing them as being added together. Okay. Now whenever you're adding two polynomials, the parentheses really aren't that important. They're only really there for looks, to say, hey, here is one polynomial and here is the other polynomial. So they're really only there to show you where one polynomial starts and the other one ends. So because there are no numbers in front of these polynomials, they're not being squared or cubed or anything, and there's no negatives in front of them, then we can just write this without the parentheses. We don't have to worry about them. Okay, so now all I need to do is find my like terms. So 4x squared doesn't have anything like with it. 7x is like with negative 6x. And negative 5 is like with positive 1. So I'm going to write this in standard form, which means my terms are going to be in descending order. So I'll start with 7x to the third. Check it off to let myself know I got it. 4x squared would be in the next one. Since it didn't have any like terms with it, I don't need to worry about adding it to anything. But now, because these two are like, I'm going to need to add them together. So 7x minus 6x, I have 7 of this thing called x, and I'm subtracting 6 of this thing called x. So I have a total of 1 of these things called x. Now remember, 1x is the same thing as x, so you don't have to write a coefficient of 1. It's the same kind of deal as saying I have 1 apple or I have a apple. Okay, so negative 5 plus 1 is, negative 4. So I got these. So now I'm done, that I've combined everything. Now here, I rewrote this second step here without parentheses. A lot of students actually skip this step, and I personally skip this step when I'm doing them myself. And I just go ahead and combine my like terms straight out of the parentheses. The reason I do that is it's actually a little easier. As long as your polynomials are each individually simplified, then there shouldn't be any like terms within the parentheses themselves. So if this guy's going to have a like term, it's going to have to be over here. So it is a little easier to not write it without, to not drop the parentheses, okay? Because then you can kind of see where your like terms are going to need to be. Okay, this time I want to find the sum of this polynomial and this polynomial. All sum means is to add them. So I just need to add these two polynomials together. Okay, now this time I'm going to leave the parentheses because it's going to be a little easier to find my like terms. I say, okay, if this guy has a like term, it's going to have to be over here somewhere. So it does. 5a to the 6th is like with 9a to the 6th. Negative 4a to the 5th is like with 6a to the 5th. And 10 is like with negative 12 because they're both constant. So I'm going to start by adding the things in yellow. 5a to the 6th plus 9a to the 6th is 14a to the 6th. Negative 4a to the 5th plus 6a to the 5th is 2a to the 5th, just adding the coefficients. Now the next term would actually be this one here. So I've already gotten my ones in yellow, my ones in blue. This is going to be the next term here, so minus 3a squared. And then the last thing is to do the constants, so 10 minus 12 is negative 2. So I got everything. Okay, so here we have the polynomial 6a cubed minus 4a squared plus 3, and the polynomial 5a cubed plus 10a squared minus 5, and I want to subtract the two. I want to subtract this one from this one. Now a lot of students get this phrase subtract A from B mixed up. Okay? Whenever you have the phrase subtract A from B, when you rewrite it as a subtraction, it's going to occur in the opposite order than it appears in the sentence. Now the way I like to tell my students to remember this is think of subtract as take away. Now remember, when you first learned how to subtract, your teacher probably said take away instead of saying subtract. So if you read it as take away A from B, it makes sense that the A would come second. So that means we're going to write the 5a cubed plus 10a squared minus 5 first, and then do minus 6a cubed minus 4a squared plus 3. Now, when we were doing the addition problem, it was the parentheses were kind of unimportant, and you may notice that here I added the parentheses in. That's because when you're doing a subtraction, the parentheses, for at least the second polynomial, are actually important. The ones around this one aren't really that important because there's no number and minus or anything in front of them. But there is a minus in front of this one. So the only way we're going to correctly do this is if we distribute the negative to every one of these terms inside these parentheses. So what we're doing is we're subtracting absolutely everything in this polynomial. So each one of these guys we're subtracting from this polynomial. So I'm going to go ahead and write this without parentheses. Now I could just drop the parentheses around the first one because they're not really important, because they just represent, hey, here's one polynomial. But these parentheses are very important. We're saying we're subtracting this entire thing. And the way I'm going to do that is by distributing the negative to each of the terms inside the parenthesis. So if I distribute it to a positive number or a positive term, it becomes negative. If I distribute it to a negative term, it becomes positive. Minus 3. Okay, now I just need to combine my like terms. Now this time I'm going to use circles and boxes. So this term is like with this one. This term is like with this one. And my two constants are like. So the first thing I'm going to do is add my ones in the box. 5a cubed minus 6a cubed is negative a cubed. 10a squared plus 14a squared is, plus 4a squared is 14a squared. Negative 5 minus 3 is negative 8. Now, if you like to use this box and circle method, I want to point out a common pitfall. Make sure that you put the box or circle completely around the sign in front of the term, okay? Because that is part of the term. This entire thing and this entire thing are the things that need to be added. So by putting the box around the sign, you're reminding yourself that this is a negative term. This is a positive term. Also be really careful when you use the box, especially, that you don't go through your negatives, because a lot of students will have the box go through the negative and then it'll look like it's positive and they'll forget to treat it as a negative term. Okay, here I want to find the difference of this polynomial and this polynomial. Now, unlike the previous one, when you see the phrase find the difference of or find the difference between, they actually occur in the same order that they occur in the sentence. So this polynomial will come first and this one will come second. So 6x squared minus 4x plus 5 minus 6x squared plus 6x minus 3. Once again, the parentheses around the polynomial on the first one aren't necessary. Okay, but the parentheses around the second one are important. We can't just drop them. The only way we're going to be able to drop them is if we first distribute our negatives. Okay, so the negative goes to the 8x squared, to the 6x, and to the negative 3, making it positive 3. Now I just need to combine my like terms. Six x squared minus 8x squared is negative 2 x squared. Okay, negative 4x minus 6x is negative 10x. And 5 plus 3 is 8. Whenever you perform a multiplication of a monomial by a polynomial, even if it's a multivariable monomial and polynomial, you're always going to do this by using the distributive property. So what I need to do is distribute this monomial here to each one of these terms. Now whenever you're multiplying polynomials, whether it be using the distributive property, using FOIL, which I'll show you in a minute, the rule you're going to use most frequently is the rule that says if you have two factors with the same base being multiplied by each other, then you just add their exponents. So to be able to multiply this, I need to distribute. Now this means that I'm going to need to multiply each of the constants in these terms by a 4. I'm going to have to add 3 more x's to each of these x's, so 3 to the exponent, because when I multiply x to the third times x to the seventh, I'm supposed to just add their exponents. So that means I'm going to just give this 3 more on its exponent. And I'm going to add 6 to all the exponents on the y's. So if you think of it as, if I had candy that I wanted to give to my students, let's say I wanted to give them 3 of this kind called x and 6 of this kind called y, then if this student already had 7 of this x kind of candy, then they're going to have a total of 10. Okay? And if this student had no y candies, then when I distribute the 6 y candies to them, they're going to have a total of 6. Okay, so they'll have 10 of the x candies and 6 of the y candies. So all you do is multiply the constants, so 4 times 5 is 20. Then you multiply the x's, and that just means you add their exponents. So x to the 10. Then you multiply the y's. Well, this one doesn't appear to have a y, so it's just when we distribute the 6 y's, or the y to the 6th, we're just going to have y to the 6th. Do the same with the next one. Multiply the 4 times the negative 3, you get negative 12. X to the 3rd times x to the 5th, so it'll be x to the 8th. X to the 6th times x to the 9th, so that's x to the 15th. Okay, so I'm just adding a 3 to all the exponents on the x, and a 6 to all the exponents on the y's. 4 times 8 is 32. This one had no x's, but when I distribute the 3 x's here, I'm going to have an x to the 3rd. And y to the 6th times y to the 4th, so it's y to the 10th. Okay, whenever you need to multiply two polynomials, what you have to make sure that you do is multiply each one of the terms in the first polynomial by each one of the terms in the second polynomial. Whenever that is a binomial times binomial, you can use what is called FOIL. Now this is just a nice way to help you remember and make sure that you did in fact do each one of the ones in the first one by each one of the ones in the second one. Honestly, it doesn't really matter which order you do it in, but this is just a nice format because in general it'll put like terms next to each other and it'll put it in descending order. Now that's not always true, but it does happen more often than not. Also, it spells out a nice word. Okay, so let's do first. So 2x times 5x, so I'll do 10. 2 times 5 is 10. X cubed. Okay, so that's first, and then outside 2x times 3, so plus 6x. Inside is negative 4 times 5x squared, so it's negative 20x squared. And then negative 4 times 3, so it's negative 12. Now here we don't have any like terms, so technically we're done. However, if you prefer to write it in standard form, where the highest degree polynomial, the highest degree term comes first, and then it goes in descending order, you may want to write it as such. Okay, now this is a multiplication of a binomial by a binomial. Now you can definitely do FOIL with this one, first, outside, inside, last, and a lot of students will go ahead and jump to that. However, notice that these two binomials are almost exactly the same. The only difference is this one has a minus and this one has a plus. Okay? Whenever you see that format, you can actually skip the whole FOIL process and use this property. If you have two binomials that are being multiplied by each other that are almost essentially the same except one is a minus and one is a plus, then it's going to be the first thing squared minus the second thing squared. So it would be, in this case, the first thing is 3x, because notice that occurs in each one of those. So it's 3x squared minus the second thing squared. And it is always minus. Okay? Well, 3x squared means you need to square the 3 and square the x, so it's 9x squared, and 4 squared is negative 16. So this is just a pattern, and when you start factoring, it is very important to remember this because you'll see where you have to go the opposite direction. But if you didn't recognize that and you just decided to FOIL it, you would still get it. And I want to show you why the formula works. First would be 3x times 3x, so 9x squared, so we already got that. Outside would be plus 12x. Inside would be minus 12x. And last would be negative 16. So notice what happened here. The two terms in the middle are like, and they're the exact opposite of each other, so they cancel each other out. And this last term is always going to be negative here because one is a minus and one is a plus. So a negative times a positive is always negative. So this will always happen. It doesn't matter what these are. If they're the same thing except one is minus and one is plus, it'll always be the first piece squared minus the second piece squared. Okay, this is another problem that could be solved using FOIL, but there's a nice formula for whenever you have a binomial squared, and it says you take the first thing and square it, so the first thing in this case is 5x. Then you do plus 2, so it's always 2, times the first thing times the second thing, so in this case the first thing is 5x, and the second thing is 7, plus the second thing squared. So it's 25x squared, because I squared the 5 and squared the x. This is 10x times 7, so 70x, plus 49. Now, I've actually found that a lot of students have trouble with this formula. I'm not sure 100% why, but if you do, you can always just rewrite this and FOIL, because most students don't seem to have a problem with FOILing. Well, as much of a problem as they may have with this formula. So just remember, whenever anything is squared, that just means you multiply it by itself twice. Okay, so then you could just do FOIL. First is 25x squared. Outside is 7 times 5, which is 35x. Inside is 35x. And last is 49. Now this can also show you where this formula is coming from. Notice the first piece ended up being that first thing squared, and this last piece ended up being the second thing squared. And notice this occurs twice. Okay, so we multiplied the 5x times the 7 twice, so that's why it just ends up being 2 times 5x times 7. So it's 25x squared plus 70x plus 49. Now, one of the common pitfalls with trying to use this formula is students forget it, and they want to try to say that a plus b squared is equal to a squared plus b squared. It is not. Please do not do that. You can't just square each of the terms. You can square the first one and the second one, but you have to remember to do 2 times the first one times the second one. Okay, so be careful with these.